So again, the key point here is that the ability to scale up and down is very important, and Kubernetes was really built to support these activities. So we're going to be working with what we call replication controllers, and they basically make sure that a certain number of pods are running. Okay, returning back to the code base we had earlier in the video series, if we look at the code here, we'll notice that we have a web ReplicationController.yaml. So let's take a look at this guy and see really what's going on internally here. So I'm going to go ahead and put the line numbers here. So you'll notice right off the bat that it's of type replication controller. That's a new type. It's not a pod or a service. It's a replication controller. And as always, there's metadata involved with it. It's got a name here and so on. Now notice we have line 9 here, which says I want 10 replicas of this. And that's the desired state. That's how many replicas we want. And the obvious next question is replicas of what? And you'll notice over here we have the spec sections starting on line 14. And notice it's the same blueprint as before. We have two containers. One of them is the REDIS container, and of course the other one is the Python container here. So just as we saw before earlier with the pod definitions, in this case it's just inside the replica controller. So what we're going to do now is run this file just as we ran the others and see what pops out on the other end, and hopefully we'll start to see the notion of 10 replicas of this pod being present in the system. So one of the things we want to do next is clean up kubeconfig. Make sure that environment variable is always set correctly whenever the machine reboots. And what we need to do is just modify bash rc. That'll make sure that we get the appropriate environment variable set during a reboot. So let's go ahead and quit out of here and go over to bash rc, which I've already modified to show you what it should look like. Go here to the bottom of the file, and I'm way down here, line 100 and above. I've got the environment variable set incorrectly here on 102, and this is what it ought to look like. It should point directly to the config file. So once I've done that, as you saw, the commands will work correctly. So if I want to make sure that takes effect, I can quit out of here. Let's go ahead and quit out of this. And then instead of doing a vim, we'll do a source, and that way you don't have to reboot. Things should work now as we expect. So at this point, we're ready to carry on here. Let's go take a little closer look at the files here to know what we want to do. We basically want to do a kubectl create with this file. And the syntax for that's pretty simple. Now you could do K like I've aliased or a kubectl. I don't want to confuse anyone, so I'm just going to keep it to kubectl now. Do a create command -f. And then we want to add in that web replication controller and do another get pods command and see what it looks like. You can see here that things happen correctly, it appears, so we can verify that by doing a kubectl get pods. Keep adding that R, get rid of that R, kubectl, and you'll notice that it's adding all 10 of those web servers. You can see them here getting provisioned, and 3 are running, so the total is 10. So it's really working the way we would want it to. It's just a one command thing to scale it up. And now as we hit this web service, we will have multiple containers, or multiple pods in this case, responding to the request. So the containers that are running is actually double this number that you see highlighted, because you have in each pod one Python web service, and in addition there's another running container there, which is the REDIS cache. We didn't scale up the database. That's a topic of future discussion, but for now the replication is working correctly. So let's quickly review what we did in this session. It was about scaling our pods. That's what it was about, specifically the pod that had the web service and the REDIS cache. Why? Because maybe we had lots of users and we wanted to be responsive and scale up. Remember, each of these pods ran 2 containers, the Python Flask web service and the REDIS cache. We used the replication controller object built into Kubernetes to do this. It's simply a YAML file, which you see right here. Let's shrink it down a little bit. And you can see it simply is a blueprint for how we want to scale up. For example, replicas 10 says I want 10 pods. Each pod defines a template. The template says which containers go into the pod. In this case, you can see the image is REDIS cache. And the other image, of course, is the Python image, the Python web service we talked about earlier. So ultimately, it comes down to providing a YAML file The YAML file has a template section I just showed you. It specifies which containers make up the scale unit. The scale unit in this case is a pod. And we already talked about that pod is basically a web service container and a Redis cache container. And to run this replication controller object, we just do it from the command line, kubectl, and then we say create -f and the YAML file name. And that's it for this section.